The main goal of the team project is to build a system to predict the areas in LA where crime is highly concentrated so that police reduce the call times and focus more on certain areas. In addition, the purpose of the project is to determine the distribution of crime, sex, and more in order to respond more effectively depending on the crime. The data set that we selected is arrest data from 2010 and 2019. This dataset is one of the categorized datasets that has been provided by the Los Angeles Police Department, which is open to developers and is based on the arrest incidents in the city of Los Angeles between 2010 and 2019. After downloading the CSV file from the webpage, the team found that all the information for arrest data from 2010 and 2019 were not shown, and data between 2017 and 2019 were missing. The team also researched web scraping in case of providing raw data from the web page. The dataset specifically focuses on the arrest information in the city of Los Angeles from 2010 and 2019. The columns include report ID, report type, arrest date, time, area ID, area name, reporting district, age, sex code, descent code, charge group code, charge group description, arrest type code, charge, charge description, disposition description, address, cross street, latitude, longitude, location, booking date, booking time, booking location, and booking location code. The columns of the data set have three different data types: float, integer, and object. There are a total of 25 columns and 131,000 rows, which is a large amount of data. So the professor recommended that we drop rows and columns to make the data manageable for the team project. After checking non-null elements in each column of raw data, 5 columns included a lot of nulls: cross street, booking date, booking time, booking location, and booking location code. These columns contain many nulls and are not relevant, so the team decided to drop them from the raw data. It looks like there are a lot of inaccuracies within the data. Some location fields with missing data are noted as 0 latitude, 0 longitude. The purpose of the team project is to predict the crime area from the dataset. Los Angeles City provides the data catalog listing various open data to encourage developers to explore and research data for the community. The web page provides multiple options for retrieving data: view data, visualize, export, and API. Many recently updated lists of datasets only include PDF files to introduce the topic without attaching a dataset. The team tried to use both the export and API options to retrieve data to the current project file. However, additional knowledge is necessary to use the API option, and the export option was convenient to download a CSV file from the web page to the local computer. The web page doesn't provide a link that the team was able to use for lab assignments. During pre-processing, the relevant columns were found, such as arrest date, arrest type code, area name, age, sex code, location, latitude, and longitude. To predict the crime area, there should be information related to the area name, location, latitude, and longitude. The beginning of the team project, location, latitude, and longitude would be used as the target. For the project update, location, latitude, and longitude are being used to provide the visual information and pre-processing. However, latitude and longitude are numerical values, but they are splitted information and are hard to manage when the categorical classification is used for the machine learning process. The team found new columns as passable targets: area ID, area name. Each area name type has a unique area ID. Area ID has 21 different area types. After examining the dataset, age and sex code columns have valid numerical data as predictors for the crime area. Before deciding what algorithm will be used for machine learning to predict the crime area, the team visually plotted the age and sex columns. The sex code columns included male and female. To make the column manageable, a new column, sex, is created as an alternative and converted from the sex code column. If the person is male, the value is 1. If not, the value is 0. While working on the machine learning, the team decided to use KNN classification because our focus is to predict the area which has 21 different area types in the area code column. Age column has a range between 0 to 100. The team classified the age column into three boundaries to see if it helps predict the crime area. After creating box plots for distributional information of the age column, IQR is observed in the 20 to 40 age range. 25% to 75% of the population are also in that range. Medians are shown about 30 and younger. For the area ID column, IQR is in the 5.0 and 15.0 range, and the median is about 11 in the middle of the total range. At the beginning of the discussion for machine learning, the team thought that 21 different area types would be problematic as the target. As the pre-work for machine learning, the team classified all area ID types into three different area types, 0 to 2. After classifying new area types, a new column area is created and used during the prediction process. The accuracy that was calculated from KNN classification becomes lower, so the team tried to use all 21 different area types as the target to predict the area. After calculating the accuracy from KNN classification, the decision tree is created to see the better predictions. The purpose of the team project was to predict the crime area from other information. Our target is the area code column, and the predictors are age and sex code columns. The team started pre-processing the dataset to make it ready for the machine learning process. During the machine learning process, the team found the accurate and anomaly information. The accuracy that is calculated from KNN classification is approximately 0.06 when all area ID types are used as a target and age and sex columns are used as predictors. Whereas when area ID types are classified as three different boundary areas to make the prediction manageable, the accuracy becomes 0.35. According to the decision tree, the Gini value, which we tried to minimize, is extremely high for all leaves when all area ID types are used as a target and age and sex columns are used as predictors. It indicates that a person whose age is less than or equal to 20.5 is predicted to commit a crime in the Hollywood area because the percentage of the sample size is higher and the Gini value is also higher. However, this condition seems less accurate due to the many classes in a target. When area ID types are classified as three different boundary areas to make the prediction manageable, the decision tree indicates that a person whose age is less than or equal to 20.5 is predicted to commit a crime in the area 0 because the percentage of sample size is higher and Gini value is similar among all leaves. The team project is to build a system to predict the area in LA where crime is concentrated so that police reduce the call times and focus more on certain areas. In addition, the purpose of the project is to determine the distribution of crime, sex, and more in order to respond more effectively depending on the crime. First, the team observed the dataset that was retrieved from the website. After removing columns that have unnecessary information and invalid data, the team did pre-processing to make the dataset ready for the machine learning process. The team chose KNN classification algorithm to predict the area ID from age and sex after transforming sex code and area ID columns to sex and area columns. After calculating the accuracy of the prediction, the team created the decision tree to visually understand which logic would give better predictions.